Welcome to TOC class. Today the topic I discuss is finite automata. Finite automata is a mathematical model which contains a sequence of input and output in it. So the input for finite automata may be you can give the finite automata input in a sentence formation, or you can given an input as a language form. Either you can give a regular expression as an input to this finite automata, and the output is a set of states. So it is an abstract model which contains some input and output in it. So what are the systems which is used to form this finite automata is called as finite state systems. Let us discuss the function of automata. It has a sequence of input. The input will be defined with the set of alphabet set sigma. This finite automata contains a set of states q and some notations. That means the transition functions will be discussed with the notation tilde, which has some starting state and a final state in it. So the finite automata shortly we can written as FA. It is a quintuple representation. Quintuple representation, which means which contains Q, sigma, tilde, S0 and F in it. Q means set of states. Sigma means set of alphabet symbols. Tilde means transition flow or transition function. S is a starting state and F is a final state. These 5 parameters will be considered as finite automata. Then, how can we represent this finite automata? In two ways, you can represent the finite automata. One is a transition diagram. Otherwise, you can represent the finite automata in a transition table manner. So, the graphical representation of flow is called as transition diagram, and the tabularized form of function of finite automata will be discussed as transition table. Let us take the example for finite automata. So I try to write a language which always contains starting with the symbol AB. So let us take sigma is equal to AB, and the formation of languages for defining L is all strings should start with AB. So either it may be AB or ABA or ABB or ABWA, AB, AB, ABBA, A triple B, like that. So all strings should start with AB. So I draw the diagram. So it's already available. Later we can able to draw this diagram by our own method. This example. So this is the simple model. So here it is a finite automata. So in which finite automata is a quintuple representation, isn't it? So how can we write it? So how many nodes are there? 3 nodes are there. So Q is a set of states which contains Q0, Q1, Q2. And what are the alphabet sets in the path? There are 2 symbols are available, that is AB. And transition function means flow. So what are the flow is there from Q0? The output path is Q0 with the symbol A. It will go to the state Q1. Then tilde from Q1 only one output state is there. It will go to Q2. From Q2 two output states are there. One is Q2A and another one is Q2B. The same state is maintained. So these are all transition functions. And the starting state of finite automata is Q0. Final state is encircled with a double circle. So this is the final state. So these are the 5 tuple representation. The same diagram will be drawn in a tabularized form. This is sigma. And the set of states are Q0, Q1, Q2. From the diagram, we can able to write the tabularized form. So in Q0A, the state is Q1. Q0B, there is no output flow. Q1A, there is no outflow. Q1B is Q2. Q2A is Q2. Q2B is Q2. This is the starting state, and final state is represented as star. So there are two main points that should be considered for finite automata. One is in a transition diagram, the final state should be mentioned with a double circle. In tabularized form, the final state will be marked as star. These 2 points should be considered. So this is finite automata. If you go for types, there are two types are there. One is non-deterministic finite automata and another one is deterministic finite automata. So what is the difference behind those two things? So I'll give the example for NFA and DFA. So this is the DFA and NFA difference. So in DFA, each symbol costs only one move. In NFA, it may be the possibility of more than one move for the same symbol. And DFA transition function is tilde D is equal to Q set of states and set of alphabet symbol sigma, which implies only set of states Q. But in NFA, there is a possibility of 2 power Q values. So what is the basic difference between NFA and DFA is, for the finite automata is also called as deterministic finite automata, but it contains only one outflow is there, that is Q0 with only one outflow. With only one outflow. This is DFA. NFA means for the same input symbol, there may be the possibility of more than one output state. So consider, look at this. Q0A, only one output state is there. But if you consider Q0A, there may be the possibility of two states. So this is called as non-deterministic finite automata. So this is the basic difference between NFA and DFA. So a deterministic finite automata, so on each input only one state is represented for the given notations. So how DFA works? Reader should be over, only we should consider the symbol from leftmost onwards. Finite control should be started with starting state. In a single step, only one symbol can be checked. This is the conditions. Language of DFA means where the acceptance is available. So if you give a correct input for a finite automata, it should go to final state. So that is the condition of language of DFA. And these are all the problems. You note it out. These problems can be solved with the help of DFA construction. So we'll discuss one by one. First, we should take the first problem, that is a string starting with 0, 1. So if any sentence is given, first we should try to write the possible strings in it. So all strings starts with 0, 1. So there is no possibility of epsilon. 0, 1, 2 letter string. 3 letter string means 0, 1, 0, 0, 1, 1. 3 letter string means, 4 letter string means 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1. Like that, the answer will be known. So how to draw a DFA? So first we should consider the first string. First string contains two symbols. So if two symbols are there, minimum 3 states. So first you should draw 3 state, Q0, Q1, Q2. This is the final state. So I encircle this final state with double circle. And you put the symbol here. What is the first string? It is 0. So first you should draw 0 from Q0 to Q1. 1 from Q1 to Q2. So this is 0, 1. So I clearly note out the first one, Q0. If you give 0, it goes to this side. So this is 0, 1. Now 0, 1, 0. So 0, it is already goes to Q1 state. 1 means it goes to final state. So next 0 means it should stay on final state. 0, 1, 1 means first 0, second 1, the remaining one should stay on final state. For all other strings, the same diagram will be implemented. So you try to check the string 0, 111, 0, 1. So we'll discuss it 0, Q0 to Q1. Q0 is the starting state, Q1 is there. Second symbol is Q1, so it goes to Q1 to Q2. Then the remaining strings are 1101, 1101. Final state is reached. So it is a correct string. For the correct string, it should goes to final state. I try to give the incorrect string. The incorrect string is 0011. If you give an incorrect strings to the DFA, it should not goes to final state. That is the condition. Consider the first symbol is 0, so it goes to Q0 to Q1 state. Second symbol is 0, there is no outflow or outpath from Q1 to Q2 or Q1 to Q0 with 0 path. So the answer is wrong, and also the system will not go to final state. So the main notation of DFA is for any if you try to write draw a transition diagram for a finite automata, for all correct input string it goes to final state. For wrong input it should not goes to final state. That is the condition behind it. Later we'll go through the next remaining problems in next class. Thank you.